In this video, we'll understand the basics of nodal analysis. So what we mean by a node? A node is a point in an electrical circuit where two or more circuit elements meet together. Okay. So before going into the equations of nodal analysis, we can try to understand some basics of how to find a node voltage. Okay, so this is our first case. So if you see here, this is our ground which is having 0 volt and this is our node A. So the value of the node A, or the voltage of node A, is given as designated as VA. Okay, the value of VA is from 0 to this point A, and when we go from ground to the point A, we are going through this particular voltage source which is having 6 volt, and we are going from minus to plus, so it is a positive change. So the value of VA is plus 6 volt because we are going from minus to plus, okay, which is a positive change. So here VA is equal to plus 6 volt. Again, in this case, we need to find the value of the node voltage VA with respect to the ground. So when we move from ground to point A, we are going from plus to minus. So here VA is equal to minus 6 volt. So this is our first particular case. Now when we are going to the second case, here we have a voltage source and another voltage source, okay, which is 8 volt and this is 6 volt. So what is the total voltage at point A with respect to the ground? Is it 8 plus 6? No, because if you look carefully, here the voltage source of 8 and voltage source of 6 are not connected together in the same polarity. Okay, when we are going from ground to point A, what happens is that I am going from plus to minus, so it is minus 6, and this is minus to plus, so it is plus 8. So the total voltage when we go from ground to the point A is minus 6 plus 8, which is equal to 2 volt. So VA equal to 2 volt in this case. Okay, the node voltage VA is equal to 2 volt in this case. Now, when you are looking at this particular circuit, this is a circuit where we are having a voltage source in series with a resistance. The voltage across the resistance is designated as VR, and we are assuming that the voltage drop is having positive on the downside and negative on the upper side. Okay, so VR and 4 volt, the combination of these two voltages will give us the value of VA. So as told earlier, when you go from the ground to VA, what happens is that here it is, we are going from negative to positive, so it's plus 4, and when we are going up from plus to minus, it is minus VR. So VA is equal to 4 minus VR. Okay, so this is how we can write the different node voltages. Okay, these are some possible cases that can arise to write a node voltage. Now let us go to a sample problem. So this is our question. Okay, this is a typical circuit. Okay, so when we tell about nodal analysis, we must keep in our mind that in the nodal analysis we are looking at the nodes and their voltages. Okay, so the first step of nodal analysis is to mark all the nodes which are in the circuit. Okay, so as I told earlier, a node is a junction which is a point where two or more circuit elements meet each other. So here this is our first node, this is a second, this is a third, and this is a fourth nodes. Okay, so we are assigning values, node voltages. Okay, this is the voltage, here is V1, it is V2 here, V3, V4. Okay, And there is another node in the circuit, which is that, see, this was our first node, which was the meeting point of V1, VA and R1. This was the second node, which was the meeting point of R1, R2 and R4. This was a third node, which was the meeting point of R2, R3 and R5. And this was our fourth node, which was the meeting point of R3 and VB. Okay. Now, another node is there in the circuit, which is that the bottom point of VA, R4, R5 and VB are all having the same node. Okay, because there is no resistance in between these 2 points, nothing in between these 2 points and nothing in between these 2 points. So all are the same potential. So this is one node. This can be assumed as one node, and that can be connected to the ground, and it will have our reference voltage equal to 0. Okay. Now we have to make an assumption. What is the assumption? V1 greater than V2 greater than V3 greater than V4. Okay. Only by making this assumption, we can mark the currents which are flowing through all our resistors and all our circuit elements. Okay. The current always flows from a higher potential to lower potential. Okay. So the current through R1 is from V1 to V2. Okay. The current through R2 is from V2 to V3. The current through R3 is from V3 to V4. The current through R4 is from V2 to the ground. The current through R5 is from V3 to the ground. So accordingly, we mark the directional currents in this circuit. Okay. So after marking all the directions of all the currents, we can move on to write the nodal equations. So what is the criteria of writing the nodal equation? The nodal equations are based on Kirchhoff's current law. Okay. And what does it say? It says that algebraic sum of all the currents associated with a particular node is equal to 0. Algebraic sum of all the currents associated with a particular node is equal to 0. So, should we write the node equations for all the nodes here? No. We need not write the node equations for all the nodes. We need to write the node equations for which our node voltages are unknown. Okay. So here we must find for which all nodes we know the node voltage. So for this node we know the node voltage is 0 volt. Okay. Over. Now for the first node V1. V1 is the voltage between this point and ground. Okay. So from this we can tell easily that the voltage between this point and ground is nothing but, as we go from ground to the point 1 is VA. Okay, the voltage is VA. Okay, so V1 is equal to VA. Now when we go from ground to the point 4, the voltage source here we have is VB. Okay, so V4 is equal to VB. Okay, so this is the second voltage that we know here. So the unknown voltages here is only V2 and V3. So we need to write the node equations for these two nodes alone. So we can write the node equation at node 2. At node 2, applying Kirchhoff's current law, that is sigma equal to 0. That is the sum of all currents associated with a particular node should be equal to 0. Algebraic sum of the currents. Okay. So we can take this node, and all the currents which are coming into a node can be considered positive, and the currents which are leaving the node can be considered negative. So here, how many currents are entering the node? One current is entering the node and two currents are leaving the node. Okay. So we can write the node equation for node 2, that is V1 minus V2, that is difference between the voltages divided by the resistance, V1 minus V2 by R1 minus V2 minus 0 by R4, that is V2 by R4 minus V2 minus V3 by R2. Okay, V2 minus V3 by R2 equal to 0. So this is our node equation at node 2. Similarly at node 3, what we can see, at node 3 also we are having three elements which are connected to node 3. Therefore we will have three currents which are connected or associated with node 3. Okay, so here also one current is incoming to node 3 and other two currents are outgoing from node 3. So using that we can write the node equation for node 3, that is V2 minus V3 by R2 and minus V2 minus V3 is the V2 minus V3 by R2 is the incoming current and the other two are outgoing current. So those two values will be negative. So minus V3 minus V4 by R3 minus V3 by R5, that is V3 minus 0, V3 minus 0 by R5, that is V3 by R5 equal to 0. So this is how we can write node equations in nodal analysis. So here we can substitute back V1 is equal to VA and V4 is equal to VB in these two equations. So we'll be getting two equations and we'll be getting two unknowns. Okay, so we can solve these two expressions so as to get our unknown voltage values, that is unknown node voltages V2 and V3. So this is a general method by which we can solve nodal analysis. I hope you understood. The description of this video will give you the link for downloading this material. Thank you.